Bag P contains a red, a blue, and a white marble, while bag Q contains a blue and a red marble. These marbles are identical except for their color. A marble is picked at random from each bag. In the first part, display all the possible outcomes of the experiment using a sample space diagram. So on the horizontal axis, we put three colors having a bag P, red, blue, and white, and on the vertical axis, red and blue. Now for the first part, we have drawn a vertical axis and put the colors red, blue, and white marbles that bag P contains. And the colors red and blue on the vertical axis that contains by bag Q. And we get six possible outcomes in the form of order pairs in in the case of in the case of sample space diagram. Part 2, Part A. With the help of the sample space diagram, find the probability that the two marbles selected are of the same color. So for this, we have already drawn the sample space diagram for all the possible outcomes. So we just have to identify the outcomes that shows both marbles are of same color. So we will highlight those order pairs or outcomes with squares. So for this, I will look inside into the order pair. This order pair shows color blue and blue. So both the colors are same in this order pair. Similarly for the second. So for this, we will count the number of favorable outcomes and divide them on the total number of outcomes. So for this, we have two favorable outcomes and the total number of outcomes here are 6. So 2 over 6 will be simplified to 1 over 3. So the probability for both marbles are of same colors is equals to 1 over 3. So for this, we will mark the outcomes with circles which show marbles are blue and red. I have a look on these outcomes. This circle shows the outcomes or represents the order pair red and blue. And this shows blue and red. So in this case, we have only two favorable outcomes. So number of favorable outcomes in this case is 2 and the total number of outcome is 6. So it will become 1 over 3. So the probability that marbles are blue and red is equal to 1 over 3. So part C, we have to find out the probability that the two marbles selected of different numbers. So to find out this, we will just use the probability of both marbles are of same color. So we'll simply subtract the probability of both shows same color from 1 to find the probability that both marbles are of different color. So from part A, the probability we have found out is 1 over 3 and it will becomes 1 minus 1 over 3 and that is equal to 3 minus 1 over 3 and it will becomes 2 over 3. So for this, Probability of both marbles are of different colors equals to 2/3. Now the question 9, 6 cards numbered 0, 1, 2, 3, 4, and 5 are placed in a box. A card is drawn at random from the box and the number on the card is noted before it is replaced in a box. A second card is then drawn at random from the box and the sum of two numbers is obtained. The sample space diagram shown below, sum of the values of sum of the values of the sum of two numbers. So it means it is given that we have to sum the two numbers. In the part 1, copy and complete the sample space diagram. So we will have to sum two numbers. So 0, the sum of 0 and 0 is 0. The sum of 0 and 1 is 1. Sum of 0 and 2 is 2. Sum of 0 and 3 is 3. Sum of 0 and 4 is 4. And sum of 0 and 5 is 5. 1 add 0 is 1. 1 add 1 is 2. 1 add 2 is 3. 1 add 3 is 4, already given in the sample space diagram. 1 add 4 is 5. 1 add 5 is 6. 2 add 0 is 2. 2 add 1 is 3. 2 add 2 is 4. 2 add 3 is 5. 2 add 4 is 6. 2 add 5 is 7. Now, 3 add 0 is 3. 3 add 1, 4. 3 add 2, 5. 3 add 3, 6. 3 add 4, 7. 3 add 5, 8. 4 add 0, 4. 4 add 1, 5, already given in the diagram. 4 add 2, 6. 4 add 3, 7. 4 add 4, 8. And 4 add 5, 9. Now 5 add 0, 5. 5 add 1, 6. 5 add 2, 7. 5 add 3, 8. 5 add 4, 9. And 5 add 5 is 10. Now in part 2, we have to find out the possible number of outcomes are there in the sample space of this experiment. So on the horizontal side, we have 6 numbers, and on the vertical side, we also have 6 numbers. So 6 times 6 is equal to 36. So the possible number of outcomes will be 36. So 6 times 6 equals to 36. Now in the part 3, we have to find out the probability that the sum of the two numbers is 7. So the probability that the sum is 7, we have to see the outcomes in the Venn diagram. Outcome in the sample space diagram, where the sum of two numbers is 7. So there are 1, 2, 3, and 4. So the number of elements in the event, all the number of favorable outcomes is 4, and divided by, since we have find out the total number of outcomes in the second part, and that was 36. So 4 over 36 will be 1 over 9. So the probability of sum is 7 is equals to 1 over 9. Since the prime numbers are 2, 3, 5, and 7, so we have to find out the number of
favorable outcomes. In other words, where the sum of the two number is a prime number. So here we have 17 and the total number of outcomes, possible outcomes is equals to 36. So we will have 17 over 36.
Now the part C, we have to find out the probability that the sum of the two numbers is not a prime number. So if we simply do to find out the probability of the sum is not a prime number is just subtract probability of the sum is a prime number from 1. And that we have find out in the part B. So 1 minus 17 over 36 will be gives us 36 minus 17 over 36. And this will be equals to 19 over 36. So the probability that the sum is not a prime number is equals to 19 over 36.
Now in the part D, we have to find out the probability of the sum of the two number is even. So we have to find out the sums in the sample space Venn diagram, which are even. So here we have 2, 4, 6, 8, and 10. So now we have to count the even sums. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So number of favorable outcome is 18, and the number of possible outcome was 36. So it will be 18 over 36. For simplifying, it will be equals to 1 over 2. So the probability of sum is even is equals to 1 over 2. In the part E, we have to find out the probability of the sum is not even. So for this, we just have to subtract the probability of the sum is even from 1, and we will get the probability of the sum is not even. So from part D, since we have found out the value of the probability of sum is even, and that was 1 over 2. So 1 minus 1 over 2 is equals to 2 minus 1 over 2, and this will be equals to 1 over 2. So the probability of sum is not even will be equals to 1 over 2. Now in the part 4, which of the two sums of the two number is more likely to occur, 7 or 8? So the number of possible outcomes of obtaining a sum is 8, while for 7 is 4. For sum is 8 is 3, while for 7 is 4. The sum of 7 is more likely to occur because there are more possible outcomes and hence a greater possibility of its occurring. Now in the question 10, it is given that set x is equals to 4, 5, 6 and y is equals to 7, 8, 9 and element x is selected at random from x and an element y is selected at random from y. The sample space diagrams display separately some of the values of x plus y and xy. So in the first question, copy and complete the sample space diagram. So in the first sample space diagram, we just need to sum the numbers horizontally and vertically with each other and get the outcome. So 7 plus 4 is equals to 14. 7 plus 5 is 12. 7 plus 6 is 13. 8 plus 4 is 12. Similarly, we will get the remaining outcomes. Now for second sample space diagram. Here we have to take the product of the numbers horizontally and vertically and we will get the possible outcome. So 7 times 4 is 28, 7 times 5 is 35 and 7 times 6 is 42. 8 times 4 is 32, 8 times 5 is 40 and 8 times 6 is 48. And similarly, we will get the remaining outcomes. So this is the complete sample space diagrams. in the part 2, part A, we have to find out the probability that the sum x plus y is prime. So the sum p is a prime number. So in the first double space diagram, we will see the sum which are prime numbers. So here we have 11, 13, 13, and 13. So there are 4 favorable outcomes. And the total number of outcomes in the first sum space diagram is 9. So 4 over 9 will be the probability for the sum is a prime number. Now for part B, sum is greater than 12. So we have to find out the sum that is greater than 12, and they are 13, 14, and 15. So here we have 1, 2, 3, 4, 5, and 6. 6 outcomes. So here we have 6 over 9, and it will be simplified to 2 over 3. So the probability that the sum is greater than 12 is equals to 2 over 3. Now, for the sum is at most 14, it means the sum is equals to 14 or less than 14. So for this, we have to see here are 8 favorable outcomes that shows that sum is at most 14 and the total number of outcomes was 9. So the probability that the sum is at most 14 is 8 over 9. Now in the part A, in the part 3, we have to find the probability that the product XY is odd. So we have to see the second sample space Venn diagram, and we have to identify the products that are odd. So here we have 35 and 45 only. So we have only 2 favorable number of outcomes, and the total number of outcomes are 9, so 2 over 9 is the probability that the product is odd. Now for part B, probability of part B that product is even. So we just have to subtract the probability of that probability is odd from 1 and we will get the answer. So 1 minus 2 over 9 and it will become 9 minus 2 over 9 and it will be equals to 7 over 9. So the probability that product is even is equals to 7 over 9. Now in part C, probability of the product is at most 40. So we have to search for the products that are less than 40 or equals to 40. So here we have 28, 35, 32, 40, 36. So here we have 1, 2, 3, 4, and 5. 5 favorable outcomes divided by total number of outcomes. So here we have 5 over 9. So the probability that the product is at most 40 is equals to 5 over 9. Now in question 11, a fair coin is tossed 3 times. So display all the possible outcomes of the experiment using a tree diagram. Since when a fair coin is tossed, then we have 2 outcomes, head or tail. So in the first toss, we have drawn 2 branches and write down head and tail at the end of these branches. And now for the second toss, again, we will get head and tails. So here we have drawn another point, starts from the head of the first coin and gives 2 branches more. So here we have head and tail. For first toss, we have 2 outcomes. For second toss, we have 4 outcomes. And for third toss, we have 8 outcomes. So this is the tree diagram for the given experiment. Now for part 2, for part A. With the help of the tree diagram, find the probability of obtaining 3 tails. So the probability of 3 tails will be equals to, we can see that is only, since we know that the total number of outcomes is 2 times 2 times 2 is equals to 8. So number of favorable outcome is 1 and total number of outcome is 8. So the probability of having 3 tails is equals to 1 over 8. Now for the probability for exactly 2 tails, here we have 3 favorable outcomes. So the probability will be 3 over 8. Now for the last one, for part C, P at least 2 tails. So last but not the second last, here we have 4 outcomes. So the probability for at least 2 tails is equals to 4 over 8. And after simplifying, it will gives us 1 over 2. So this will be 1 over 2. Now for last one, probability obtaining no tails, it is equals to probability having all tails. So here we have 1 favorable outcome. So total number of outcomes is 8. So 1 over 8 is the probability for the obtaining no tails. Question 12. The 3 ladies are happily awaiting the arrival of their bundles of joy within the year. Display the sample space of the genders of the 3 babies using an appropriate diagram, assuming that the babies are equally likely to be either a boy or a girl. Hence, find the probability that there will be a total of, number 1, the 3 boys. So first we have to tell which appropriate diagram we should use in this question. Since we have 3 ladies in the statement, so it means we have to use the tree diagram here just because it is a multi-stage probability experiment. So for first lady, we have boy and girl, and for second lady, we have 4 possibilities, and for third lady, we have 8 possibilities. So the number of elements in the sample space will be 8. Now in part 1, we have to find the probability that there will be a total of 3 baby boys. So for this, from the tree diagram, we can see that the probability of 3 baby boys is equals to P of B, and that is equals to 1 over. So the favorite outcome in this case is only 1. So it will be divided by the total number of outcomes. So that was 8. So the probability for 3 baby boys is equals to 1 over 8. Now in part 3, we have to find out the probability that there will be a total 1 baby boy and 2 baby girls. So we have 3 favorable outcomes, BGG, GGB, and GBG. So the number of favorable outcome is 3, and this will be divided by the total number of outcomes, and that is 8. So the probability having 1 baby boys and 2 baby girls is 3 over 8. Now for part 2, we have to find out that the probability
will be a total of 2 baby boys and 1 baby girl. So for this, we have 3 favorable outcomes: BBG, GBB, and BGB. So here is the favorable outcomes are 3, and the total number of possible outcomes is 8. So the probability for having 2 baby boys and 1 baby girl is equals to 3/8. Now in question 13, a spinner with 3 equal sectors and a spinning pointer as shown in the diagram, and a fair coin and used in a game. The pointer is spun once and the coin is tossed once. Each time the pointer is spun, it is equally likely to stop at sector. So in the first part, we have to display all the possible outcomes of the experiment using a tree diagram. So first we will display the outcomes of the spinner, and they are red, blue, and orange. Here R is red, here blue is B, and here orange is O. And now the further branches will show the outcomes for the a fair coin is tossed for each sector. So the total number of outcomes here, is 6. Now in part 2, we have to find out with the help of the tree diagram that the probability of getting red on the spinner and tail on the coin. So the probability for red and tail is 1/6. Because here we have only one favorable outcome in this regard, and the total number of outcomes was 6. So the probability for red and tail is equal to 1/6. Part B, we have to find out the probability of getting blue or orange on the spinner and head. So it means the probability of blue and head or orange and head. So the probability having blue and head is 1/6, and the probability having orange and head is also 1/6. So it will be equals to 2/6, and after simplification, it will gives us 1/3. So that the probability having blue and head or orange and head is equals to 1/3. Question 14. The Venn diagram shows the number of teenagers who play cricket and the number of teenagers who play soccer in a neighborhood, where C is the set of the teenagers who play cricket and S is the set of teenagers who play soccer. So the number of teenagers will be 24, add 21, add 25, add 11, and it will be equals to 81. So the number of teenagers will be equals to 81. Now for the part 1, we have to find the probability that the teenager plays either cricket or soccer. Now we have to find out the probability that teenager plays either cricket or soccer. For this, we will put it equals to the number of elements in the C union S. The C union S means the teenagers who play cricket or who plays soccer or who plays both these sports. And it will be divided by the total number of possible outcomes. So we will just put the values of the number of teenagers who play soccer plus the teenagers or number of teenagers who play cricket plus the number of teenagers who play both, and divided by the total number of teenagers. So it will be equals to 70/81. To find out the probability that teenagers only plays cricket is equals to number of elements in the C union S complement divided by number of elements in the set eta, and that will be equals to 24, just because in the Venn diagram we can see that the students who play on the cricket is 24, and it will be divided by the total number of outcomes, and that we have found out in the part 1, and that is 81. So the probability that the teenager only plays cricket will be equals to 24/81. Now in the part 3, we have to find out the probability that the teenager plays cricket. So for this, we have number of students, number of teenagers
who plays cricket divided by the number of teenagers. So the number of teenagers who play cricket, we can see from the diagram, Venn diagram, that is 24 plus 21. So 24 plus 21 is divided by 81, and it will gives us 25 over 45 over 81. So the probability that the teenager plays cricket is equals to 45 over 81. Now in the part 3, we have to find out the probability that the teenager plays cricket. So for this, we have number of students, a number of teenagers who plays cricket divided by the number of teenagers. So the number of teenagers who play cricket, we can see from the diagram, Venn diagram, that is 24 plus 21. So 24 plus 21 is divided by 81, and it will gives us 25 over 45 over 81. So the probability that the teenager plays cricket is equals to 45 over 81. So further simplifies to 5 over 9. So the probability that the teenager plays cricket equals to 5 over 9. Now in the part 4, we have to find out the probability that a teenager does not play either sport. So for this, we have the number of elements in the set C union S whole complement divided by the number of teenagers and of eta, and that will be equals to 11 over 81. So the probability that the teenager does not play their sport is equals to 11 over 81.